Hi, I figured it's really a lot easier for me to put this in a video and post it for us to discuss than it is to write a lengthy email and a series of screenshots and all this other stuff. So I think I can um, summarize what it is that we're dealing with here. So the problem is, how do we show these? How do we show these cross sections? I'm going to take A prime as digitized. Our A prime cross section, our section line, this which is essentially this blue line right here with a 20-foot buffer about each side, is the cutting plane that we use to slice through our lithology, our model that we've done inside of EVS MVS. And then in addition to that, what we want to do is include the soil borings within that buffer for our different analytical data. So that's what's going on here. So just to sort of belabor the point here, it's this buffer and it's this transect and all the points within there that we're really looking at, okay? So the first time I did this, the first thing we came up with, it looked like this. And quickly, sort of what we realize is that, well, because we're actually, this thing went straight down the middle, you can see that it does and planimetrically in 3D sort of what you have right here, and that is depending on which perspective, we can either see all of these samples on one side of the line or not. Okay, so that's that. Let me go ahead and put this back. Okay, so then what I did next, I said, well, our next possible solution was to go ahead and what if we didn't do it like that? What if we moved the line back? What if we took and said, okay, well, let's just push that line back and then we look at everything in front of this cutting plane. Okay, and so that's what this looks like when we do that. We've essentially used, instead of this transect right here, we've just pushed it back a little bit so that we can see, our soil borings. I then talked with, we had another brief discussion, and one of the things that was kind of evident then is that that's really kind of a problem because there's this there's sort of an this isn't a static flat separation between the fill and native layers, and how do we know where we're actually intersecting these how do we know where we're actually where the soil borings and the detections or exceedances rather are intersecting which layer? So okay, that's fine, and here's maybe one way to tackle it is to provide sort of ISO lines across the face of it. And when we do that, it's instead of relying simply on this graph, this thing right here, our labels on our elevation plane, we're actually projecting the actual elevation data onto this cutting plane, and that kind of gives us kind of a better picture. So that's sort of maybe one way to address it, but it still doesn't address the foreground effect. We can kind of, the reader can kind of see what's going on, but you still have this whole issue right here where a lot of these samples, some of them are as much as like 40 feet ahead of this surface. So because we are really interested in the exact intersection of the soil borings and our lithology, it was suggested that we actually digitize the cutting plane through every single point so we know that there's a contact point. At first I thought, well, yeah, this is a great idea, but you can quickly see how this is going to shake out sort of from here. So if we do this kind of like this, it gets pretty hairy pretty quickly, and it's also going to be a big problem when we get to BB prime, because then how does this line then look like? If you try to connect the dots here, kind of crazy, but no worries. We went ahead and we're going to try this anyway. And when we do it, you can see that we get this sort of accordion effect. Now we have in fact gone through every boring, but right here, you know, it's just kind of, it's kind of a mess. It doesn't, I don't think this is really what we intend to do here. It's also worth noting that while it is possible to do a true fence diagram with something like this and sort of straighten it out two-dimensionally, we can do that, but you cannot do it with the soil borings. They will not automatically adjust to correspond with a two-dimensional fence. It's sort of, it's a limit of the software that I've run up against. I actually have sort of looked at this, and you know, it's explicitly stated, you know, in bright red, that that's not really something that you can do very well. Not something that you can do, period. Okay, so where does that leave us? So I kind of came back to this idea of using our original our original delineation of our A prime cutting plane, and then just, you know, we can then maybe take and use the you know, call back the transparency here on this, something kind of like this, and then we can still sort of see, okay, well, what's in front and what's behind. I don't know if this is going to be confusing to our reader or viewer or whatever. You know, maybe we play with some sort of calling a transparency kind of effect here, so they can kind of get at that, and then we can see exactly sort of where these lines are. That way you're not 40 feet away from any given point. You're sort of splitting the difference. And then, you know, we can play with some other visualization things, like maybe what we do to make this a little bit more readable is to take off minor and also major axes lines, and then you really just have the elevation of the strata projected onto this cutting planar surface. So just a thought, but this is a discussion that maybe we should have once the project team has had a chance to sort of, you know, maybe mull this over. So that's sort of the, you know, that's kind of where it's at. So we'll talk about it. Thanks.